Now, after the review of the basic material, so we now can study the Garman model in more detail. So remember, the model said there's a market maker that try to fill the demand supply. So we need to model how the demand supply come, because we have to depart from the idea of a static world. We have the dynamic. The demand comes in a dynamic fraction. So that's why we need to use Poisson process. So we assume the buy order arrive with a Poisson process for lambda A. So this rate is lambda A, but it's not a constant rate. It really depends on the price PA. So this is a buy order, so it's a demand function, right? So that's why we have a downward sloping demand. So the price, when the price goes up, the rate goes down. So that's why the rate decreasing with the price. So it's a standard demand function. So because people come in buy the stock, then they have to pay the money, right? So that means that for this period, the buy order also arrive at this rate lambda A, right? And that's why the cash arrive at lambda A times PA, okay? Because to buy 1 unit of stock, you need to pay PA. So this is the graphical illustration of the arrival of buy order. Similarly, we will model the sell order also arrive at Poisson rate lambda B, and also this is a function of PB, because this is a supply function, right? So it's a bid price. So this is a increasing, so it's a standard upward sloping supply curve. So because people come to sell, right, then the cash also departing from the dealer, right? Because people come to sell, you get a stock, but you leave the cash, so cash departing at the rate lambda B times BB. So this is the graphical illustration of the departure of the arrival of sell order. So it's an upward sloping supply curve. To summarize, we have cash arrive at lambda A times PA and leave at lambda B times PB. But for the stock, it leaves at the rate of lambda A times PA and leaves at the rate of lambda B times PB. Okay, here, after some mathematics, we are not going to cover, but we can understand intuitively. The market maker follow the similar problem because of Poisson process. Cash arrive at this probability. Okay? So the numerator is the cash arrival rate. The denominator is the arrival rate of cash and departure rate of cash. So look at the denominator is the rate that cash arrive and departure. So similarly, the leaves probability is the numerator is the rate of cash leave, and the denominator is both the arrival rate of the cash and departure rate of cash. So similar for stock is the same. The stocks leave at the rate of a fraction of the numerator is lambda A and the denominator lambda A plus lambda B, and it arrives at the complementary probability.